Hello, my name is Patricia Vanova, and my presentation will be about finite element analysis of bridges with encased continuous shear connectors. The main goal of our research is to develop a bridge design that would be more effective in shear transmission, easier to construct, as it could be easily prefabricated and use less material, as you will see later in the presentation. For the experimental research, the following materials were tested: the concrete, which was of 66 megapascal strength, and steel with yield point of 315 megapascals. To use less material, the parts of the concrete where tension was present were removed from cross-section, as you can see in this picture. Two types of connectors were analyzed. You can see one on the left side, which is a puzzle-shaped connector, the so-called double, and then on the right side, the strip with additional curved reinforcement welded under the wall perpendicularly from both sides. The experimental study consisted of 3 4-point flexural tests onto each type of connector in 6-meter-long beams. Before the experimental study, the analytical study was done. The expected maximum force for both types of beams was just under 270 kN. Here you can see the results from the experimental study of the puzzle-shaped beam. The end of the first linear part of the graph, where the beam still acted elastically, was marked at 350 kN. Here are the results of the second type of the strip, which had a slightly higher resistance at around 370 kN. For numerical study, both types of beams were modeled in Abacus software. Here are some input data that were put into the software. The dynamic explicit step was chosen to perform the analysis with times set to 1.0 seconds. The interaction, important for any composite structure, between steel and concrete was modeled via general contact with additional friction between the two materials set to 0.93 and 0.95 respectively. Load model was done via amplitude, where time was set to the time in step and loading cycles were converted into amplitude, with one equal to maximum loading condition during the experimental program. Two loading cycles, which were present in the linear part of the graph to prove that the beams were still acting elastically, were also modeled. The models were meshed with 3D elements, tetrahedrons for steel and concrete, and hexahedrons for reinforcement. Here are the results of the numerical study of the double. As you can see, the Abacus model copies the initial linear part of the graph closely enough. Here are the results of the second type of shear connector. In conclusion, after the numerical study of the beams, the parametric study can be done. Also, fatigue tests and finite element analysis of the push-out tests need to be finished in the near future. Thank you for your attention.